Alright, you guys, we are in the next lesson using coordinates to compute perimeter. Now, perimeter is something you learned back in middle school. It's when you add up all the sides of whatever kind of figure it is. I don't know what kind of figure we're about to look at, so I'm going to open up and see what I'm looking at. Looks like it says right triangle, so I'm going to be looking at a right triangle. Now, perimeter means you have to have all three sides, and you add them together. So I'm sure we're going to be doing something like that. All right, part A, question number 1. Let's see, what are the coordinates of the vertices of ABC? Using the coordinates to find the lengths of AB and AC. All right, so we're going to be using the distance formula. Or I guess we could use GeoGebra. Just says to use the coordinates to find the lengths. All right, so let me get the coordinates for A, B, and C. All right, so A, starting at the origin, is right 2, up 2. A is going to be 2, 2. You know what, I'm just going to put a comma here. Save my space. B, well over here, so I'm going to start and go right 6, up 2. B is going to be 6, 2. C, there's C, so I'm going to go right 2. Down 1. That means C is going to be 2, negative 1. They're asking me to find the length of AB, and they're asking me to find the length of AC. Well, distance formula. I'm going to write that out for you guys. It's a big old square root. It's going to be x2 minus x1. And that's squared. Again, really all I'm doing right now is just writing out the formula for you. Y2 minus Y1. So you're seeing me do these superscripts and all this other stuff to get it to look right. All right, well, there's your distance formula. All right, so I'm looking for AB first. All right, so A is our first ordered pair, which means this is x1, y1. B is our second ordered pair. That means 6 is my x2. 2 right here is my y2. So first order pair is 1 and 1. Second order pair, they're both 2s, x2, y2. All right, now it's just going to plug and chug. So I'm going to have the square root. I'm going to put this in for you guys. Let me move it so you guys can see what I'm doing. All right, so sitting in the x2 position is the 6. Minus x1 is the 2. And I'm going to square that. Oop, how do I get out from under there? Whoa, what happened? What happened? Technology, great till it don't work. All right, 6 minus 2. Close my parentheses, squared. Plus. All right, there we go. All right, now we got to do our y. So y2 was this 2. Minus y1. Y1 is this other 2. All right, hang on a second, you guys. I got somebody at my door. All right, you guys, so let's see. Then we got a close parenthesis. There we go. Close parenthesis, and we got a square. And again, you guys, this is just part of the formula. Just plugging and chugging into that formula. All right, so now we got to do our math. So we got a square root. 6 minus 2 is 4. Now 4 squared is 16. 2 minus 2 is 0. 0 squared is 0. So basically you have the square root of 16. You're looking at the square root of 16. Because 16 plus 0 is, well, 16. And the square root of 16 is a 4. So AB is 4. And again, if you don't believe me, there's a 16. I'm going to square root that. You get a 4. All right, now I need to find, what's next? AC. All right, so I'm going to do A, which is x1, y1. C, which is x2, y2. AC. All right, I'm going to pull up my distance formula for you guys. All right, let me move this a little bit so we can see what we're talking about. All right, so let's see. X2 is 2 minus that 2, which is x1 squared plus. All right, so our y, so we got a -1 minus 2 squared. Okay, I'm just going to do it right here. I have to go in and out all the time. All right, 2 minus 2 is 0. 0 squared is 0. -1 minus 2 is a -3. -3 squared is a 9. 0 plus 9 is 9. So I'm going to put that all in. All right, you guys, so listen. The square root of 9 is 3, so it looks like AC is going to be a 3. So I'm going to submit that. Okay, so they did it a different way. Well, all right then. Good, great. Looks like they used GeoGebra. All right, so I did it the long way this time. That's unusual for me. Okay, so use the distance formula to find BC. Okay. So let's see. We got 6, 2. We got 2, -1. I'm going to have to put those in on us so I can remember. 6, 2, 2, -1. All right, so let me move this. We're going to use the distance formula again. All right, so square root. All right, so then the x2 position is 2 minus x1 is the 6. I'm going to close my parenthesis and I'm going to square that. Plus sign. Now I'm going to do my y, so open a parenthesis. So we got y2, which is -1 minus 2. And square that. All right, so let's see what I got here. 2 minus 6 is a -4. -4 squared is 16. -1 minus 2 is a -3. -3 squared is a 9. 16 plus 9, 25. Well, the last thing is the square root of 25. And the square root of 25 is a 5. And the reason why is because 5 times 5 is 25. So there's part B. All right, part C. Now, I told you guys just a minute ago, anytime you're doing perimeter, you add up the 3 sides. Well, my 3 sides were 3, 4, and 5. This is a 3, 4, 5 triangle, so we're just going to add those together. So let's see. What's 3 plus 4 plus 5? All right, looks like it's 12. All right, cool. Part D. Now use GeoGebra to measure the length of each side and use those links to calculate the perimeter. Do you get the same result that you obtained in part C? Take a screenshot. All right, so we're going to find our length. So go up this angle icon and select distance or length. A to B was 4. B to C is 5. C to A is 3. So yes, 3 plus 4 plus 5 is what I had earlier. 3 plus 4 plus 5 is 12. 5 is a 12. And yes, I can't spell yes. Yes, they are the same. All right, wants me to take a screenshot. So I'm going to go and do that. Boop. All right, so let me put that in. Insert image. Choose file. Desktop. Open. All right. Booyah. Submit. All right, well, that was all question 1. Wow, okay, so question number 2. Okay. Now you will use GeoGebra to help you compute the perimeter of a quadrilateral. All right, so same thing as a triangle, guys. You have to have all 4 sides of a quad. So let me open this up. All right, looks like I got some sort of, maybe looking at it like a trapezoid. Might be a trapezoid. The reason why is because it looks like this line DC and this line AB might be parallel. If they are parallel, it's a trapezoid. If they are not parallel, not a trapezoid. Probably just some kind of quad. All right, let's see what's going on. What are the coordinates of the vertices of the quadrilateral ABCD? Use the coordinates to find the length of DA. All right, so I got a first. All right, where's the A's down here? So from the origin, you're going to go left 5, down 4. So A is going to be -5, -4. B. Where's B? B is up here. I'm going to go from the origin, right 1, up 4. So B is 1, 4. C, right there. I'm going to go right 4 and up nothing, down nothing, which means C is 4, 0. All right, D, right 1, down 4, right 1, down 4. That's going to be D at 1, -4. All right, they want me to use the coordinates to find the length of DA, which is the distance formula. All right, I'm using D, I'm using A here. All right, so let's see. Use the coordinates to find the length of DA. Well, it doesn't say use distance formula, so I'm not going to this time. All right, so I'm going to go to the angle icon, select distance or length. I'm going to click on A, then D. Looks like I got AD as a 6. Cool. Part B. The 3 remaining sides of ABCD are not purely horizontal or vertical. You will use the Pythagorean theorem to find the lengths of these sides. Start with AB. Place a point E at -5, 4. All right, so -5, 4. I'm going to put an E right there. So I'm going to come over here to point -5, +4. Put an E right there. All right. So I know what's going to happen. They're going to get me to draw a right triangle. So they're going to get me to draw a segment AE and EB. So I'm going to come over to segment. I'm going to connect A to E and connect B to E. Now I have a right triangle. And I'm going to use the Pythagorean theorem. They've already told me that, so I've got to find the lengths of these 2 legs of this right triangle. All right, now you have a right triangle AEB, and AB is the hypotenuse. Find EB and AE. Okay, those are the 2 sides I told you we just got to find. Using the coordinates of AB and E, and use the Pythagorean theorem to find AB. Okay. So basically, if I come over here and find distance, E to B is a 6. E to A is an 8. They want me to use Pythagorean theorem with the 6 and the 8. Well, Pythagorean theorem, in case you've forgotten, is A squared plus B squared equals C squared. And I do my superscripts, and we've learned that in a previous lesson, so if you watched any of my lessons, you know how to do that. All right, so my 6 squared plus, I thought I hit it again, there we go, plus 8 squared are my 2 legs, and that equals C squared. Grab your calculator. 6 squared plus 8 squared is 100. And the opposite of squaring is to square root. We're basically going to square root this 100, and we're going to end up with a 10. So 10 is our C. All right. So again, that's the length of that segment AB they want us to find. Okay. So again, what you just found is the length from A to B is 10. This is 10 right here, from A to B. All right, there we go. All right, part C. Next, find the length of BC. Okay, so we're going to place a point F at 4, 4. So come over here, click on point. 4, 4 is right 4, up 4. So we're going to put a dot right there on the grid. We're going to connect these 2 segments to make a right triangle, just like we did before. B to F, F to C. So here's my right triangle. I need to find the length, which is 3. Just count 1, 2, 3. All right, so there's 3. This we need to count. So there's 1, 2, 3, 4. It's a 4. And in all honesty, if you've been watching any of my videos or sitting in my classroom, you know this is a 3, 4, 5 triangle. It's one of those triples that I always talk about. So this is 3, this is 4. Then this right here, BC, is 5, automatically. There it is, 3, 4, 5. So BC is 5. This is one of those ones you really want to have memorized, you guys, for the ACT. All right, part D, we're going to find the length of CD. So we're going to place a point G at 4, negative 4. So I'm going to come over here to point. Whoa, what happened there? I'm going to go right 4, down 4, put a dot. They're going to label it G. All right, I'm going to draw segments to turn this into a right triangle. Click on D, then G, G, then C. Looks to me like it's the same thing as this one up here. I've got a 3, a 4, which makes DC a 5. It's a 3, 4, 5 triangle. Just to prove it, there's 3, there's 4, CD is 5. When you've got those little 3, 4, 5 triangles memorized, it does tend to help and make things go faster. All right, calculate the perimeter by adding all the side lengths. All right, so my last side is 6, so I've got 10 plus 5 plus 5 plus 6. 10 plus 5 plus 5 plus 6. All right, so let's see. The 5 and 5 is 10. 19 plus 10 is 29. Plus 6 would be, what's that, 35? 35. 19 plus 10 plus 6 is, whoa, what happened there? Let me try that again. 19 plus 10 plus 6 is 35. Uh-oh. What did I put 9. Oh my gosh, where in the world did I get 19 from? Y'all supposed to correct me, y'all. Let's do that again. That's going to be 1026. Somebody reach through the computer there and get me on that one. I don't know where I got 19 from. And I said it was a 10. All right, part F. All right, last one. I got a self-eval coming up. All right, now use GeoGebra to measure the length. Oh, I've already done that. Yeah, I already did that because I wanted to prove it as I went. All right, so do you get the same result? Yeah, you're going to get the same result. So I apologize. I'll do it again. 10 plus 5 plus 5 plus 6. 10 plus 5 plus 5 plus 6. That's going to be 26. I did better that time. So self-eval. Yeah, well, usually I give myself a 5. I'm going to say I give myself a 4 this time. I messed up. Human error, you guys. All right, so let's see. Perimeter is when you add up all 4 sides. And if you've got some kind of weird-looking object, sometimes you can turn those into right triangles and, do the Pythagorean theorem. Just another option unless you want to do distance formula. And, I've had people do distance formula. It's all good.